Welcome back. Get your book and open it to page 133. We're in lesson 9.3 talking more about slopes. We have 3 learning targets. We're going to show that a linear function has a constant rate of change. We kind of did that in lesson 9.3. We're going to understand when a slope of a line is positive, negative, 0, or undefined. And then we're going to identify functions that do not have a constant rate of change and understand that these functions are not linear. All right. You have seen that for a linear function, the rate of change is constant and equal to the slope of the line. This is because linear functions increase or decrease by equal distances over equal intervals. Look at the graph below. Question 1. Over the interval 2 to 4, so if you're noticing right here, here's 2, here's 4, and they kind of map it out for you. How much does the function increase? So how much does it go up? So from 2 to 4, how much do we rise? We increase by 1. How do we know that? Because we start at a y value of 4, and then we jump to a y value of 5. Over the equal interval from 8 to 10, how much does the function increase? So we have 8, and we're going up to 10. How much do we increase? Again, it's the same thing. We're increasing by 1. Well, how do we know that? Because we were at y equals 7, and then we're jumping up to y equals 8. So that's our rise. We're rising 1 number. Okay? So does everyone see that? I'm jumping up 1 box here, 1 space. We are jumping up 1 box here. Next page. Question 3. The table below represents a function. So in our first column we have x's, in our second column we have y's. Question A says determine the rate of change. Remember that rate of change is another word for slope, and we use the variable or the letter m for slope, between the points negative 862 and negative 634. So we're going to use the slope formula for this. Okay, remember the slope formula is y2 minus y1 over x2 minus x1. So I'm going to label these points to help you out. This is our first point, x, y, and because this is our first point, it gets 1s. Okay. This right here is our second point, x, y, so it gets 2s because it's our second point. So let's plug it into the formula. So we have y2, which is 34, minus y1, which is 62, divided by x2, which is negative 6, minus x1, which is negative 8. So 34 minus 62, type that into your calculator if you don't know it. I want you to get the answer to question A. I got negative 28 over 2 negatives here make a positive, so this becomes negative 6 plus 8, which is 2. These are both even, they're both divisible by 2, so I know that it reduces to a negative 14, so that's my answer. All right, question B. I'm going to label the points for you, and then I want you to pause the video and I want you to answer the question by yourself. Okay, so this is x, y, x, y. First point gets ones, second point gets twos. Use this slope formula right here, and you're going to calculate the slope. Go ahead. So y2 minus y1 over x2 minus x1. All of these two negatives turn into a positive. So this becomes negative 1 plus 1, which is 0. 1 plus 1 is 2. I have 0 cookies for 2 people. They get 0 cookies. So question A, we use 2 points from the table. Okay, hopefully you recognize that. We use these 2 points right here from the table. Question B, we use these 2 points from the table. We got negative 14 and 0. Are those the same? No. So is this a linear function? No. Why or how? Because we have different slopes, or rate of change is not constant. Linear means straight line. So if I'm going down 14 over 1, and then I'm going up 0 over 0, or up 0 over 2, like it doesn't work. It's not going to be a straight line. So no, this is not linear because we do not have a constant rate of change. We do not have the same slope. All right, here's what I would really, really, really like you to do. For question 4, 5, 6, and 7, so almost the entire rest of the lesson, I would like you to do this by yourself, okay? You're going to get into a rhythm and you're going to get the hang of it. What you need to do, I'm going to set you up and help you. You are going to look at these graphs. You are going to pick 2 points on these graphs. Remember, when we are picking 2 points, we're looking for a good intersection point between an X and a Y axes, or intersection point, or tick mark. So I see a good, oops, my board isn't very calibrated. I see a good point right here, okay? And I see another good point like right here or right there, okay? So you can draw on your stair step if you want, and you're going to count your rise over run. Okay, I see a good point here, and I see a good point here. Remember, when you're counting rise over run, reduce if possible. Okay, so you're going to find the slope for 4A, all 3 graphs. Find the slope for 5A, for 6A, for 7A. Pause the video, spend time figuring out the graphs for all of these. You can do it. So my slope for this one, I'm rising 1 and I'm running 4. I'm rising 2 and I'm running 1, and that reduces to just 2. This one I'm rising 5 and running 1, and that just reduces to a 5. Question B, describe the slope of any line that rises as you view it from left to right. The slope of the line is positive. So what I want you to think about is I want you to think about going up a hill or up a ramp. We read a graph just like we read a sentence from left to right. These graphs are increasing or inclining, so our slopes are positive. Okay, do question 5 if you haven't already done so. Like 2 points. Count your rise over run. If I draw in my stair step here, I'm going down 3 over 1, so my slope is -3. Here I'm going down 2 over 1. Here I'm going down 3 over 4. All of these slopes are negative. How do I know that? If I look at my graph or my line from left to right, it's falling, it's dropping, it's declining, it's going down. Think about we're skiing down the hill or we're going down the wheelchair ramp. Okay, so if we have to go down, then we have a negative slope. Question 6. There are lots of different points here. Okay, I could pick a point here and here and think about if I'm rising and running, did I go up any? No, I'm rising 0, I didn't go up, but I'm running 1. If you type that into your calculator, 0 divided by 1, 0 cookies for 1 person, my slope is 0. Okay, let's say I put a point here and over here. My rise is 0, I'm running 6, so I have 0 brownies for 6 people, they get 0. Let's say I put a point here and here, I'm rising 0 and I'm running 4. I have 0 candy bars for 4 people, they get 0. All 3 of these are horizontal lines. The slope of any horizontal line is always 0. This is 0 fun. The slope is always 0. Okay, I'm going straight. I'm going up 0. 0's in the numerator. We're rising 0. We have a 0 slope. These ones look different to me. Okay, so let's say I put a point here and here. This time, my rise is 2. My run, I'm going over, is 0. Type that into a calculator and see what it says. Okay, or if I put a point here and here, I'm rising 5 and running 0. What does your calculator tell you? Your calculator does not say 0. It might say this if it abbreviates, undef, which is actually undefined. Okay, so the slope of a vertical line is always undefined. So we cannot divide by 0, so it's undefined. All right, question 8. I would like you to fill it in by yourself. You can do it. If I'm going up, it's positive, down is negative, a horizontal line is 0, and a vertical line is undefined. Oops. Came unplugged. Alrighty. Question 9. Suppose you are given several points on the graph. Without graphing it, how could you determine whether it's linear? Well, remember, if the rate of change is constant, the function is linear. How do we find the rate of change? Remember, we can use our slope formula. We can find the change in y divided by the change in x. If my rate of change is different, then the function is not linear. In your own words, I want you to answer questions 10 and 11. You can do it. How can you tell from a graph if the slope of a line is positive or negative? Well, first, remember, make sure you are looking from left to right, just like you read the sentence. Okay, then if the line goes up or it increases, then the slope is positive. If the line goes down or decreases, the slope is negative. Describe a line having an undefined slope. A vertical line has an undefined slope. Why is it undefined? Because we cannot divide by 0. The x-coordinate in the denominator is 0, and when we divide by 0, we get undefined.